Good morning, everybody, and welcome to another video from Advanced Math Tutoring. This question was brought to me by one of my Calculus 1 students. A rod of length 30 centimeters is attached to a piston on one side and a wheel of radius 10 centimeters on the other side. The angle between the x-axis and the point where the rod touches the wheel is phi. The wheel spins at a rate of 3 revolutions per second. How fast is the piston moving relative to the center of the wheel at phi equals 90? So the first thing we should do before we even attempt to solve the problem is to just fill in what the problem gives us. And so we know the length of the rod, that's 30 centimeters, and we know the radius of the wheel. Now, these two numbers don't change. The thing that is changing is the distance between the piston and the center of the wheel, and so we'll call that h. And so what we want to find is dh dt. That's the problem. That's what the problem is asking. How fast is the piston moving relative to the center of the wheel? And so we are given one other piece of information, and that is that the rate of the wheel, or the wheel, turns at a rate of 3 revolutions per second. And that means d phi dt is equal to, so it turns at a rate of 1 revolution every third of a second, which is 2 pi every third of a second, or 6 pi for every second. And that's a constant rate of 6 pi. And that's all we are given. And so one might try to find dh dt in the following method. Let's say we know that dh dt, this would be equal to dh d phi times d phi dt. And that's just chain rule. And this is great because we have d phi dt. The problem gives us it. So our job will be to find dh d phi, or at least get a function of h in terms of phi. And that's going to be the challenge. And me and the student that I was working with, we looked at this for 30 minutes and finally had to resort to online materials. It's not an obvious setup. However, when the thing that gives it away is in our original problem, we have two sides and an angle. And no matter what the angle is, even if it's not 90 degrees, if you have two side lengths and an angle, you should automatically think law of cosines. And so that's what we're going to do. And I'm going to set up my law of cosines in this form. C squared is equal to a squared plus b squared minus 2ab cosine of phi. And now, so in our case, C is going to be 30, A is going to be 10, B is going to be h. And so when I write all of that out, we get, I'm just going to do the math in my head, we get 30 squared, which is 900, is equal to 10 squared, or 100, plus h squared, minus 2 times 10, or 20. B is h cosine of phi. And now let's just move everything to one side. And I'm just going to move the 900 over to the other side. And so our equation becomes h squared minus 20h cosine of phi. And then 100 minus 900 is minus 800. And this is all equal to 0. And so now it looks like we have a quadratic equation. So let's just apply quadratic formula, and we get h is equal to 20 cosine of phi plus or minus square root of 20 squared cosine squared of phi plus 3200. And this is all over 2, which we can do some simplifying. So obviously the 20 can cancel out one of the 2's. Now here we can pull out a 20 squared from both of these terms, and that's because 3200 is equal to 400 times 8, and 400 is 20 squared. So 3200 is 20 squared times 8. And so we can pull out a 20 squared from underneath the radical, and then that 20 will cancel with the 2. And so once we clean up this equation, we get the following. H is equal to 10 cosine phi plus or minus 10 square root of cosine squared phi plus 8. But this is exactly what we wanted. This is what we wanted from the beginning, which is have h in terms of phi. But remember, we need d phi, dh d phi. So let's just take the derivative of this. And so dh d phi, that's equal to, this first one is the easier one. We know the derivative of cosine phi with respect to phi, that's negative sine phi. And the 10 stays where it is because it's a constant. And I'm just going to choose the plus side. It doesn't matter which one we do, they'll both give you the correct answer. So here's the tougher one. We can already pull the 10 out. So I'm going to use the chain rule here. I'm going to set my u equal to cosine squared of phi plus 8. So then du d phi, that's equal to derivative of cosine squared of phi is negative sine of 2 phi. And that's just an identity that you're going to have memorized, or you could derive it by product rule. And so what we have here is 10 times the square root of u. And when we take the derivative of that, we get 5 over root u times du dx, d phi. And so when we put all of that together, we get the beginning, the negative 10 sine of phi plus, or I guess minus, since we do have that minus sine 2 phi, minus 5 sine of 2 phi all over square root of cosine squared phi plus 8. And so here is dh d phi. And so the original question is, what is dh dt when phi is equal to 90? Now, we said dh dt is equal to dh d phi times d phi dt. And so let's just plug in phi equals 90 into our equation and then multiply by 6 pi. So when we do that, our sine 2 phi becomes 0, because when phi is equal to pi over 2, sine of 2 times pi over 2 is sine of pi, and sine of pi is 0. So this entire term goes to 0 when we plug in pi over 2. And we're only left with this term. And this term is negative 10 times sine of pi over 2. Sine of pi over 2 is 1, so this is all negative. This is negative 10 times 1, which is negative 10. And one last step is to multiply by d phi dt, which is a constant of 6 pi. So the end result is negative 10 times 6 pi, which is equal to negative 60 pi. And that's your answer.